Hello everyone, my name is Toga Erbora. I am from Florida International University, and today I'll be talking about the measurement of the t-dependence of the beam symmetry of photoproduced eta mesons at GlueX. So we are interested in understanding the photoproduction mechanisms of eta mesons at GlueX energies between 8.2 and 8.8 GeV. This can be understood by a quantity known as sigma, which is the beam symmetry. If sigma is positive 1, we have vector meson dominance and natural parity exchange. If sigma is negative 1, we have unnatural parity exchange and axial vector meson dominance. These are all in the T-channel exchange process. Compared with previous GlueX results, we were limited in statistics, reaching a measurement only good up to the momentum transfer value of 1.1 GeV squared. But now we have access to more GlueX data, allowing 6 times more statistics and potentially further depth in the momentum transfer regions. So we'll be showing preliminary results for those today. So in order to produce the etas, we need linearly polarized photons emitted by a coherent Bremsstrahlung to be incident on the proton target. Using the GlueX setup, we're able to track the decay of the eta and understand and identify the final states. We have drift chambers focusing on the charged particles, and we have calorimeters mapping out the neutral particles. Various schematics show some of the features of this process. An invariant mass spectrum allows us to see the peak signal and understand the background as well. We have the signal plus background peaking right around the eta mass, and the background fit to pretty much a linear exponential function. But we believe this background largely comes from the omega going to pi 0 gamma decay with only 2 photons coming out. It is expected that with the consistency of the background, we're able to extract the asymmetry from this sideband region and plug that in to correct for the peak region asymmetry. But before we can get the beam asymmetry, we need to extract the phi angular distributions. For convenience, due to being complements, we're able to use the proton's phi angles. And we have parallel orientation yield, perpendicular orientation yield, and taking 2 samples, we're able to cancel out detector-specific variables when considering the sum of the two, which allows us to also see various acceptance-specific features. And we are able to take the fraction of the difference over the sum to extract the yield asymmetry. The corresponding calculations are shown here. We are able to take the right-hand side of this equation and match it with the right-hand side of this equation and directly extract sigma via a fit. Now, when we consider the sideband region, we're able to correct for that by taking the difference between the asymmetries and correcting by a quantity known as the dilution factor. And with all of this work done, we arrive at the preliminary result for the beam asymmetry as a function of momentum transfer. For low momentum transfer, we're able to maintain values very close to 1, denoting natural parity exchange, and also in agreement with past GlueX results and some of the models. For high momentum transfer, we're still working on it, though we expect natural processes to relatively dominate. So we're in the process of applying systematic corrections on the beam asymmetry result, and also taking Monte Carlo simulations to better understand the signal and background. We expect similar progress will be achieved in the eta going to pi 0, pi plus, pi minus. This work was partially supported by the US DOE, and GlueX thanks various funding agencies for making all of these studies possible. Thank you everyone for your attention. Thanks for watching.